Hello everybody from Math 1435, Pre-Calculus 2. It's Professor Wenson here again with a video on your KnewtonAlta homework for section 7.4 part 2 titled Use Given Trigonometric Ratios to Find Other Ratios. Alright, so in this section I'm going to start off on paper. I want to just go over a little instruction beforehand. I'm going to kind of try to sum up some of the more instruction you've got. I mean, we'll look at some other things later probably, but I want to get into what's being discussed in this section 7.4 part 2. So in previous videos, in previous sections, you've seen me draw, the unit circle a lot. And we talked about, when you draw an angle in standard position, and that angle takes you to a certain point on the unit circle, one unit away from the origin, and you can very easily determine what the cosine of the angle is, the sine of the angle, and so on. Well, here in this section 7.4 part 2, we're going to kind of extend that notion from the unit circle to any circle centered at the origin. So this is representing any circle centered at the origin with a radius of, say, r units. Right? So remember, the unit circle had a radius of 1 unit. So every time you see r here, if you want to replace r with the number 1, then you'll be talking about the unit circle. But we're not going to be dealing with only the unit circle here today. Alright, so there's the x-axis, y-axis, coordinate plane. And now I'm going to put up now I know it's going to look very similar to my picture of the unit circle, only now it's, instead of this being the point 1, 0, this is the point r 0, right? And r, radius is a positive quantity, right? R is always positive here, okay? So here's r 0, and then, this would be 0 comma r up here, and then over here, same distance from the 0 comma negative r, the opposite of r. This is negative r comma 0, sorry. And then down here, negative r, r units below the origin, so coordinate negative r, and this is the point 0 comma negative r. And then I'm drawing in a circle, a very, very rough circle. I apologize if this isn't a perfect circle. Right, so here's a circle, centered at the origin, with a radius now of just any radius, right, represented by the letter r, and r is positive. All right, so very similar to the picture of a unit circle I've drawn, I know. And then we'll draw an angle. Right, so an angle in standard position, remember that. We draw our angles starting from the positive x-axis. So starting at the unit on the circle here at the point r0. You can draw it clockwise, counterclockwise, clockwise, whatever. All right. But I draw an angle. Again, I'll just draw this angle here in the first quadrant. Remember the quadrants 1, 2, 3, 4. Well, let's draw an angle here in the first quadrant. And there's so here's where the angle ends, the terminal side. This is, I'll call this angle T, or you can call it theta, or whatever. And we've traveled from the point R0, if I sweep that angle out, we have traveled up here to a point with an x-coordinate and a y-coordinate, right? I'll call these x-coordinate and y-coordinate just x and y. All right, and then just as I've done in previous videos, previous pictures, from this point, x comma y, I draw a segment perpendicular to the x-axis, perpendicular to the horizontal. And do you see what I've just created is a right triangle. Right, a right triangle. Now the lengths on this right triangle, this horizontal length, right, is just the x-coordinate of the point xy. The vertical length, right, is the y-coordinate of the point xy that I'm at on this circle. But this time, right, this time I'm not talking about, just the unit circle here, right? This time my hypotenuse might have a length other than 1, right? This is representing a circle of any radius. And that radius I called r. So now the hypotenuse has a length r, where again r is always positive, right? X might be negative, y might be negative, but this r is always positive. Please know this. All right, the r, the distance to the origin. Okay, so this is for any circle then. The relationship we're seeing then that the cosine of an angle. Right, so the cosine of this angle too. Remember, cosine in a right triangle is adjacent over hypotenuse. Is the x-coordinate of the point that I'm at divided by its distance to the origin. So not just x anymore, right? Remember, for the unit circle, when r was 1, when the radius was 1, it was just x over 1. But now if we're on some other circle, the cosine of our angle is the x-coordinate of the point on the circle divided by that, the distance that point is from the origin, right, which is the radius called r. Same thing for the sine, right? The sine of our angle t here is, looking at this right triangle I drew, is the opposite length. So the y-coordinate, right, the y-coordinate of the point that I'm at on the circle, divided by the hypotenuse, which is again not 1 but r, right? The radius of the circle, the distance to the origin. So the sine of an angle is y divided by r, the y-coordinate of a point that I'm at on the circle, divided by the distance that point is from the origin. And then the tangent. Now the tangent doesn't change. The tangent of this angle, again looking at my right triangle here, remember is opposite over adjacent, the y-coordinate divided by the x-coordinate. All right, and then for the other three, remember the reciprocal of cosine is called secant. Right, so the secant would be the the radius of the circle divided by the x-coordinate of my point. All right, just flipping over the cosine. The reciprocal of sine was cosecant, and that would be the radius of the circle divided by the y-coordinate of the point. Right, just flipping over the sine, the reciprocal of sine, cosecant, right? And the reciprocal of tangent was called, cotangent. And that would just be the x-coordinate of the point divided by the y-coordinate of the point, right? The reciprocal of tangent, flipping over y over x to be x over y. Okay. But again, at least remember these two. Because if you know those two, you're pretty much set. You can get the other four very easily, which I'm going to get into on the next page. Right, so I'll keep referring back to this picture though, as we have some properties or some identities. So some trig identities. Now, an identity is just a statement that is always true for any value from the domain, right? So if you look here from this previous picture and the stuff in this box here, look at what happens if I were to take the sine of that angle t and divide it by the cosine of the angle t. Well, what would I get? The sine of the angle was, remember, the y-coordinate of my point divided by the radius of the circle divided by, and then the cosine of an angle was, the x coordinate of the point on the circle divided by the radius. And if you were to multiply the numerator and denominator by r, the r's would cancel and I'd be left with y divided by x. Well, where else have I seen this? Y divided by x is the tangent of the angle that was mentioned, right? The central angle. All right. So this is called a quotient identity. Now this doesn't come up later until a later section, but I just wanted to bring it up now because it's one of the easier ones to pull out. So a quotient identity is, the sine of an angle divided by the cosine of that same angle will be equal to the tangent of that angle. Okay, that's a big one. All right, and if you take the reciprocal of both sides, flip this over, you'd have the cosine of an angle divided by the sine of that same angle will be equal to, the reciprocal of this side. The reciprocal of tangent is cotangent, the cotangent of that angle. Right, and you can try it out with the y, because if I just flip these, it would be x over y, right? And x over y is cotangent. So these are called the quotient identities. Right, again, not really coming up in this section, but I just wanted to point them out because they're pretty easy to point out. Sine divided by cosine is tangent. Cosine divided by sine is cotangent. All right, and you already know the reciprocals, right? 1 divided by cosine is secant. 1 divided by sine is cosecant. 1 divided by tangent is cotangent. Right, you already know the reciprocal ones from earlier. All right, now looking back at this picture again, here's some other identities. Now this one comes from the fact, looking at my picture again, you have this right triangle. And remember the Pythagorean theorem. Now this identity actually shows up in this section, section 7.4, part 2. A right triangle here. You see I have x squared, right? Wouldn't it be x squared plus y squared equals r squared, right? The sum of the squares of the legs is equal to the square of the hypotenuse. X squared plus y squared equals r squared. Now if I manipulate this a bit, if I just take this equation here and divide everything by r squared, I'd have x squared divided by r squared plus y squared divided by r squared equals 1. Right, that's just taking this equation here from my picture and dividing everything by r squared. Well, look at this first term. X squared divided by r squared, that's just x over r squared. That's the cosine of the angle squared. So this is the cosine of angle t. Now here's some notation you're going to see. That might be a bit tricky. When you take a trig function, cosine, sine, tangent, and raise it to powers, they don't put the powers out here like you're used to. They put the power after the name of the function. So when you see cosine of t and then squared, this means this. It means taking the cosine of t and squaring it. All right, it means multiplying the cosine value by itself. All right. So this x squared over r squared is, cosine squared of t plus, and then y squared over r squared, the second term, that's the sine of t squared. See, y over r, y squared over r squared would then be sine squared. All right, the sine of angle t squared. All right, and this is equal to 1. All right, I'm going to put this in a different color box because this is actually coming up in this homework assignment. All right, this is true for any angle. For any angle, I'll put some stars next to it even. All right, asterisks. If you're given an angle t, any angle, the cosine of that angle squared, right, times itself, plus the sine of that same angle squared. times itself, will always be equal to the number 1. All right, and this is huge. Okay, this is again for this section. There is a whole objective about this particular identity. Okay, and there are some other ones, but we'll get to those, I'm sure, at a later date. All right, we can manipulate this equation a little bit more and get other ones. Okay, so we've got, now we're working not just on the unit circle, but of a circle of any radius, right? And again, if you just let r be 1, if r equals 1, then you're on the unit circle and all the r's become 1 over here. And you have a few identities that I'd like you to know. All right. The sine of an angle divided by the cosine of an angle is the tangent of that same angle. And then you can flip those. Cosine divided by sine is cotangent. And also, big one here, for any angle, the cosine of that angle squared plus the sine of the angle squared will always be equal to the number 1. All right, so let's get into some problems. I've kind of summed up all the most of the instruction. So you see this objective here that I'm looking at. Again, you're not going to see things in the same exact order that I am, or the same exact problems. But we're asked to use the Pythagorean identity to answer the following question. All right. So here we're given that cosine theta. All right, so some angle theta. The cosine of some angle theta is negative 2 times the square root of 13 over 13. And theta is an angle that ends in quadrant 2. What is the sine of theta? All right, now I'm going to do this actually a couple ways. One is I'll do it with the Pythagorean identity. And another way I'll do it is with I'll draw a picture. And actually I'll draw the picture first. All right. So go into some paper. So we're asked to find the following. We're given that the cosine of theta equals negative 2 times the square root of 13 in the numerator over 13 in the denominator, and we're also told that theta ends in quadrant 2. I'll just put Q2 for quadrant 2. So I'm going to draw a picture of this. All right. Okay, I'm going to draw a picture of this. So I know the angle's got to end in quadrant 2. So here's what I'm going to do. All right. So again, anytime you draw an angle, and it's, on the coordinate plane standard position, you're always starting from the positive x-axis. And it doesn't matter which way I go. I can go counterclockwise, I can go clockwise, positive angle or negative angle, as long as I end in quadrant 2. So here is an angle that ends in quadrant 2. Right? So this is theta here. And there's a point on there's a terminal side. What I'm going to do is I'm going to have this point here be on some circle. Right? It's on some circle of a radius that I don't know yet. All right? Well, I'm going to have it be on radius 13. Let's watch what I'm going to do. All right. So here's an angle that ends in quadrant 2, as they told me. And then let's say it intersects some circle, right? You can draw a circle as big as you wish, and the terminal side intersects the circle at some point. And as I've done in a previous picture, I'll take this point here, drop a perpendicular segment to the horizontal axis, and that gives us, a little right triangle here. Right? This gives us a right triangle with a the reference angle. Right? Hopefully you recall reference angle. This angle here between the terminal side and the horizontal axis, that's theta prime. Remember the reference angle? And I'm going to set up the sides of this right triangle here so that the cosine of the reference angle is 2 times the square root of 13 over 13. All right, so off to the side, I'm writing down, here's what I'm doing. I'm setting up a right triangle with, reference angle theta prime such that the cosine of the reference angle is 2 times the square root of 13 divided by 13. Right. So remember how cosine is, right? In a right triangle. Cosine, the numerator, I'll just say is the adjacent side. I'll put A for adjacent. Denominator, hypotenuse. Remember, cosine's adjacent over hypotenuse. So in my picture, this length here, the horizontal length, the adjacent length, I'll say has a length of 2 times the square root of 13. Right? And the vertical length, the other leg, I don't know. I'll call this y because it's vertical. Right? If it were horizontal, I'd call it x. And then the radius, which is the hypotenuse, right? The radius, that distance from that point to the origin, is 13, right? This is, again, this fraction here, this fraction I was given, I'll think of as adjacent over hypotenuse. So the radius here is 13. Right? Okay, now, something I like to do, just to make things easier on myself, since this horizontal distance is to the left of the origin, this is a negative x. I want this to be the x coordinate, right? I want the horizontal length to represent the x coordinate of the point that I'm at. So it would be a negative x coordinate. So I'll say this is negative, 2 root 13. And the y coordinate I don't know, and the radius is always positive. Okay, please be sure that radius is always positive. I'll write that again over here. That distance to the origin. And then we have a point on our circle here. Right? This point has an x coordinate of negative 2 times the square root of 13, an unknown y coordinate, and it's on a circle. It's on a circle with a radius of 13. Okay, so I'm basically going to be referring back to this picture, right, with these relationships that I wrote here. Right. Remember, the cosine of an angle is the x coordinate of a point you're at divided by the radius of the circle. The sine of an angle you draw is the y coordinate of a point you're at on a circle divided by the radius of that circle. If you keep those two in mind, you can get the other four pretty easily. So now I just want to find the y coordinate. I want to fill in this right triangle. All right, so that's like the second part. And I want to solve the right triangle, or I'll say find the missing pieces, find the sides of the right triangle that you create. So that's using the Pythagorean theorem. Right? So in this picture here, we have a, now again, it doesn't matter if it's positive or negative because I'm going to be squaring it, but I'll just write, negative 2 root 13 squared plus, this y squared. It's equal to the hypotenuse of the radius here squared, 13 squared. All right. So this is negative 2, negative times negative, it'll be positive. Again, it doesn't matter if you write this as positive or negative, you're going to be squaring it anyway, so it'll be positive 4 times 13. All right, 2 times 2, and then the square root of 13 squared is 13. 4 times 13 is 52. All right, so that's 52. Plus y squared equals, and then 13 squared is 169. And then I subtract 52. 169 minus 52 is 117. And then I take the square root. Now y equals, now again, you could use plus or minus, right? Remember, these solving a squared equation, a quadratic equation, positive or negative. But notice here on my picture, we're in quadrant 2. The y coordinates are positive, so I'm going to use the positive square root of 117, which this can be simplified. This is actually 9 times 13. This is 3 times the square root of 13. It's the square root of 9 times the square root of 13. Okay. Alright, so that's the y coordinate of my point. Right? So this side here is 3 times the square root of 13. This coordinate, 3 times the square root of 13. Alright, so now I have all the missing pieces. Right? I have the x coordinate of my point, negative 2 root 13. I have the y coordinate of my point on the terminal side that's on this circle of positive 3 root 13, and the radius of 13. Okay, now that I have this, all this information, we're asked to find the sine of this angle, the sine of theta. And remember from earlier, again, this picture, these relationships are always happening. The sine of an angle I draw in some circle is the y coordinate of the point on the circle I stop at divided by the radius of that circle. All right. So I'll write that here again. It's the y coordinate divided by the radius, which I have. The y coordinate of this point I found is 3 times the square root of 13, or the square root of 117. I think it'll take that as well. Divided by the radius 13, right, the radius of this circle. And here is what I'm going to enter. Alright, so I'm going to be doing this a bunch. Right? This is the first example, probably a little confusing. Hopefully you understood the picture I drew. Alright, and it should be positive, right? Remember in quadrant 2, y coordinates are positive, and your sine is related to the y coordinates. Right? R is always positive. So if y is positive, sine is positive. If y coordinates are negative, sine is negative, and so on. Right? I've talked about this in my previous videos, where certain trig functions are positive or negative. Yeah, so let's go back to enter this number. Right? So the sine, and it says report your answer as a rationalized fraction. All that means is that you don't have square roots in the denominator, right? Rationalized. So we have 3 times the square root of 13 in the numerator divided by 13 in the denominator. Right, and submit. Now, let me show you how to get the same thing. Now, that was one way to do it, with a picture. Another way was with the title of this objective was use the Pythagorean identity. All right, so I'm going to show you this once because personally I like drawing pictures. But let me show you another way to get the same value. All right. Okay, so same question. We're given the cosine of an angle, and we know where that angle ends, and we're asked to find the sine. Well, remember that Pythagorean identity I mentioned earlier? That states that the cosine of an angle, and this time I'll use theta instead of t because they have theta there, squared, plus the sine of that same angle squared should be equal to 1 all the time. Now we are told the cosine. So I'm replacing cosine theta with negative 2 times the square root of 13 divided by 13. And that is being squared, right? This is the cosine of theta squared. Plus the sine of theta squared should be equal to 1. All right, now when I square this, right, again this is 52 in the numerator, over 13 squared is 169, plus, and we're going to be solving for the sine of theta. Right? Sine theta squared equals, and then just to get them to have the same denominator, common denominator, 1 is 169 over 169. All right, then I would subtract 52 169ths, and we get the sine of theta squared would be equal to 117 169ths. Right. and then I take the square root, meaning the sine of theta would be equal to positive or negative. Now you got to pick. I'll show you. The square root of 117, which we saw earlier, was 3 times the square root of 13. All right, that's the square root of 117. Divided by 169, the square root of that is 13. Now you can't use both of them, right? The sine of an angle is going to be either positive or negative. It's not going to be both. So you have to choose based on where angle theta ends. Based on where theta ends. So we are told, right, that theta ends in quadrant 2. Remember, in quadrant 2, y coordinates are positive, meaning that the sine will be positive. So, since theta is in quadrant 2, the sine of theta then would be the positive one of these, right? I choose the plus, would be positive 3 times the square root of 13 over 13. All right, and that's exactly the same answer I got here, right, drawing my picture. This is called the Pythagorean identity. Right? The cosine of an angle squared plus the sine of that same angle squared will be equal to 1. And then if you know a cosine, you can solve for sine. If you know the sine, you can solve for cosine. And just be careful though, because you'll have a positive or negative solution, like you see here, plus or minus. You just have to remember what quadrant the angle's in to know if you're using the positive sign or the negative sign. Okay, so that was an alternate way of doing the same problem. And they do that here. All right. All right. So next. So this objective coming up is understand the relationship between the quadrant in which an angle falls and the signs of the trig functions of that angle. I have discussed this before. All right. In fact, I actually have a picture still from a previous video. I'll show it to you here. You can click on more instruction if you want, but here is, this was on using reference angles. But remember, in quadrant 1, if your angle ends in quadrant 1, the x coordinates are positive, the y coordinates are positive, so all the trig functions will have a positive value. If your angle ends in quadrant 2, the x coordinates are negative, meaning cosine will be negative. And if cosine's negative, its reciprocal secant will be negative. And the same thing for tangent and cotangent, because remember, tangent and cotangent involve x and y is positive here. So if y is positive and x is negative, your tangent and cotangent will be negative. So, but y coordinates are positive in quadrant 2. So the sine will be positive, as we just saw in my last example, and its reciprocal, right, cosecant, will be a positive value, and all the other 4 will be negative. In quadrant 3, x coordinates are negative, y coordinates are negative, so everything's negative except for tangent and cotangent, because remember, tangent was y divided by x and cotangent was x divided by y, and they're both negative, so dividing them will make it positive. All right, so if your angle ends in quadrant 3, the tangent of that angle, the cotangent, will be positive, and all the other 4 trig functions will be negative. And in quadrant 4, if your angle ends in quadrant 4, x coordinates are positive, y coordinates are negative. So x coordinates are positive, so cosine and secant will be positive, and the other 4 will be negative. So I've already discussed this in previous videos and with that picture. So here we're told the tangent of an angle is negative. Which quadrant could theta lie? So look at my picture again. Let's pull it up here. If the tangent is negative, well, think about where is the tangent positive. Quadrant 1 and quadrant 3, you'd have a positive tangent. So in quadrants 2 and 4, you'll have negative tangents. So quadrant 2, quadrant 4, your angle theta could be if the tangent were a negative number. All right. Again, they go through the explanation and all that. Same kind of question. The cosecant of an angle theta is negative. Now remember, if the cosecant is negative, that means the sine is also negative, right? The reciprocal of cosecant. And if the sine is negative, that means your y coordinates are negative. And then it says the cotangent of the angle is also negative. Now remember, cotangent and tangent will be negative in the same quadrants, and we just saw that was quadrants 2 and 4. So looking back at my picture, I'll pop it up here. So we're in quadrant 2 or 4 because it says, cotangent's negative. But we see from the first part that sine would also be negative. So it can't be quadrant 2. Quadrant 2 sine is positive, so it's got to be quadrant 4. In quadrant 4, sine will be negative, so cosecant will be negative, and the cotangent will also be negative in quadrant 4. So the only quadrant that makes any sense for this angle theta here is quadrant 4. All right. So again, it's just a lot of reasoning about x coordinates and y coordinates. Right? So pay attention. All right. So there's another one on using the Pythagorean identity. All right, so again, I'm going to do it where I draw a picture. You can do the identity with cosine squared plus sine squared equals 1. You can do that on your own if you wish. I'm going to do that thing where I draw a picture because I think that can be a bit tricky when you first see it. All right, so I'll pull up some paper and I'll draw a picture where we represent the information given to us. So we are told that the cosine of an angle called theta is positive 3 times the square root of 13 divided by 13. All right. And we're also told that theta is in quadrant 4. Theta ends in quadrant 4. I'll just put Q4. All right, so I'm going to draw a picture where I have an angle theta ending in quadrant 4. In fact, I'm just going to draw a circle right now of radius r, right? I don't know what r is, so I'm not going to put any numbers. Just there, 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 and there. I'll just draw some circle. Now again, this isn't the unit circle. All right, this isn't the unit circle. It's going to be of a different radius, or another radius r. And I'm drawing an angle theta that ends in quadrant 4. Right? So starting here at the positive x-axis. Now again, it could be this way, it could be that way. Doesn't matter. So here we go. I'll draw a negative angle that ends in quadrant 4. So here's theta. It's a negative angle measure. I just drew a negative one, but it ends in quadrant 4. That's all that's important to me. And it intersects, some circle at a point. I would like to find the coordinates of this point. So this point that's on the circle I just drew, that's on the terminal side of my angle, I'm going to draw a little segment. Again, draw a segment perpendicular to the x-axis, the horizontal axis. All right, so you see what I've just created here, a right triangle. Now the reference angle would just be the opposite of this, right? Because this is a negative angle I drew. So, the reference angle, theta prime, would be the same measure, just positive. Right? And I'm going to set up the sides, right, the sides of this right triangle so that this information holds. Right? We are told the cosine of theta is, this 3 root 13 over 13. So the numerator of this will be the adjacent side. Adjacent to theta prime, right? Again, I'm always going to the reference angle. All right? And in this case, my reference angle and my angle are the same, basically, just opposites. So. And then the hypotenuse, which is the radius, right? Hypotenuse r. Right? So I'm going to set this little right triangle up in my drawing, so that here, the adjacent side to the reference angle has a length 3 times the square root of 13. And since that is to the right of the center, that is going to be my x-coordinate. I'm going to leave it positive. Right? So the x-coordinate of this point is 3 times the square root of 13. The opposite side I do not know. And since it's vertical, I'll call it y. Right? So the y-coordinate I don't know. And the hypotenuse, right? Again, opposite the 90-degree angle here. That's the radius r is 13, right? So this circle I drew has a radius of 13, right? Circle the radius of 13. Now we're asked to find the sine of this angle again. And in order to find the sine, I need the y-coordinate. Remember, the sine is the y-coordinate divided by the radius. The cosine is the x-coordinate of my point divided by the radius. Alright, so I use the Pythagorean theorem with this right triangle I just drew. So I have 3 times the square root of 13 squared plus this other side, this y-coordinate squared, equals the radius squared, right, 13 squared. Now when I square this, that'll be 9 times 13, that'll be 117, plus y squared equals 169, where we saw 13 squared earlier. I subtract 117, so y squared be 52, and then y equals, again, it would be plus, technically the solutions to this would be plus or minus the square root of 52. That's 4 times 13, so 2 times the square root of 13. But you can't use both, right? You can't use both. Which one would I use? Well, I'm in quadrant 4. The y-coordinate is negative, right? I'm going to use the negative one because I'm in quadrant 4. So this y-coordinate here, this side here is negative 2 times the square root of 13. Right? The y-coordinate here, negative 2 times the square root of 13. Alright, so I have the x-coordinate, I have the y-coordinate of a point on this circle, and now I have the radius. Right? So the sine, right, we're asked to find the sine of this angle of theta that I drew. Remember, that's equal to the y-coordinate of a point on your circle divided by how far that point is from the origin, right? The radius, r. And again, r is always positive. This time, though, the y-coordinate is negative 2 times the square root of 13 divided by, and then r is 13, right? And again, it should be negative, right? In quadrant 4, y-coordinates are negative, sine would be negative. And that's what I'll enter. All right. Actually, I'm just going to do the cheat and show you. There you go. Right? I would enter, see, negative 2 times the square root of 13 over 13. Beautiful. All right. And now they go through using the identity, right, where they plug into. Now this is just the same identity where you solve for. Remember, it's cosine squared plus sine squared equals 1. So you just get sine. If I'm solving for sine, I subtract cosine squared, take the square root, and all that. Right? You gotta pay it, and then after you take the square root, you gotta pick. Do I use the positive value or the negative value? And that'll all depend on what quadrant you're in. All right. Now this objective I haven't done yet. Again, so I click on more instruction if you want. But find the values of all trig functions given the value of one of them. So if you know the value of one of them, you should be able to find the other 5. Right? Remember, there are 6 of them. Now they're only asking for 2 of them, but I'll show you how to find out the 5. It's going to be the same thing I've done in the past couple examples. I'm going to draw a picture where I have a right triangle. A right triangle with the reference angle in it. All right. So again, I'm going to a piece of paper. So we're given this information. We're told that the tangent of some angle theta is negative 5/12. And we're told that theta is in quadrant 2 this time. Right. So again, drawing a picture. Same thing. Notice how very repetitive I am with all these problems. I'm going to draw a circle. Now, it is not the unit circle. Okay, it is not the unit circle. It's just a circle with a radius of r centered at the origin. Right, so again, I don't know what this r equals. Right? All these points are r units away from the origin. I'm going to draw an angle that ends in quadrant 2. So it could be, again, it could be a positive angle, a negative angle. It doesn't matter. I'll draw a positive angle. And again, I just need it to end in quadrant 2. Right. And then, that terminal side will hit the circle I drew at some point. Now my goal is to find the coordinates of this point and the radius of the circle I have drawn. Right. So just as with the last examples, this point on the circle that's on the terminal side of theta, right, I should have drawn, here's theta, and here's theta prime, right? Here's the reference angle, right? The angle formed by the terminal side and the horizontal axis. So I'm going to make a right triangle, right? By doing this, you take the point on the terminal side, you take the point on the circle, and I draw a segment perpendicular to the horizontal axis, perpendicular to the x-axis, and you see the right triangle. Got this side here, hypotenuse, this side here. Okay. And then looking at this right triangle with the reference angle in it, I'm going to label the side lengths, and we'll find the coordinates of this point and the radius using the information I was given. Now, this is the tangent. So remember, tangent of an angle in a right triangle, the numerator is the opposite side. This is opposite the theta prime, opposite the reference angle. So opposite the reference angle, this should have a length of 5 units. And would it be positive or negative? Well, that's, it's above the x-axis, so that's positive, and that's the y-coordinate. All right, so the y-coordinate of this point is positive 5. Then the denominator tells me the adjacent side, right? Adjacent to the reference angle in the right triangle I've drawn. So the adjacent side has a length of 12. And because that's left, right? It's left of center. I'll call it negative 12, right? And that's the x-coordinate, right? The horizontal leg represents tells me what the x-coordinate of the point on the circle is going to be. So that's negative 12. So I have x-coordinate negative 12 for this point, y-coordinate positive 5, based on the information that was given to me. Right. Now the only thing missing in this right triangle is the radius, the distance to the origin. And I can use the Pythagorean theorem. Right? Negative 12 squared, the horizontal length squared plus the vertical length squared, right? 5 squared, will be equal to the radius squared. So this is 144 plus 25 equals r squared. This is 169, and we've seen that already. And so r is equal to positive or negative 13. Which one do I use? Well, remember, r is always going to be positive. R is a positive quantity when I talk about the radius of the circle. Right? So positive 13 for r. So this is another. So here it is again, another circle with a radius of 13. Right, again, not the unit circle. Okay, and then using this picture, and I know the point on my circle on this terminal side, I know the radius, the x-coordinate, y-coordinate, the radius. I can find anything now. So let's find them all. So the cosine, right? The cosine of this angle, remember back on my first picture, the cosine of an angle drawn on in some circle is the x-coordinate of the point that you stop at divided by the radius. So that would be negative 12/13. And it should be negative. Remember, you're in quadrant 2. X-coordinates are negative. Cosines related to x-coordinates. Cosine should be negative. And then if I have the cosine, then we have the secant. Right? So the secant of theta would be negative 13/12, right? Just the reciprocal of that. Remember, cosine and secant are reciprocals. The sine, remember the sine of theta is the y-coordinate of your point on the circle divided by the radius of the circle. The y-coordinate is 5, the radius is 13, positive 5/13. And if I have the sine, then I know the cosecant, right? The cosecant of theta be the reciprocal of this, 13/5, 13/5. And we are told the tangent already. So then the cotangent of theta, remember the cotangent is just the reciprocal of the tangent. The tangent was negative 5/12. The cotangent of this angle would be negative 12/5. And there we have it. I was given the value of one trig function and told where the angle ends, and I was able to find the other 5. Right. Now in the assignment we're only asked for the secant. Right. Now the secant I said was negative 13/12, and be careful if you don't enter the negative sign. Right, you got to pay attention. Make sure if something's negative, actually put the negative sign. Right? It'll mark you wrong if you don't. And then they asked for the sine of theta. The sine of theta was the y-coordinate divided by the radius, 5 divided by 13 in my picture there. Okay, positive. And there you go. All right, and I think they might. I think they use the identities. You could draw a picture though. Right. So I might do this again, unless we have a new objective. Yeah, this is the last. I've done 3 objectives so far. There are 4 of them in here. This is find the values of all trig functions given coordinates on a unit circle. All right, basically a circle. All right, notice again, we're not working with the unit circle every single time here like we were before. You've seen it already. I've done several examples now where the circle that we are on has a radius of 13, not 1. Right, the unit circle had a radius of 1. So here, I'll do the same thing where again, I'm just drawing. I'm basically drawing the same kind of picture every single time. So here, the angle theta, drawn in standard position, right, meaning starting at the positive x-axis, goes through the point negative 15, negative 8. This point here is not on the unit circle, right? This is definitely further than 1 unit away from the origin. Find the secant of theta. All right, so again, I'll draw a picture of this in a very similar fashion to the way I've been drawing all the pictures. All right, so coordinate plane, a circle with some unknown radius, right? I do not know the radius of this circle yet. It's not 1 all the time. And we're drawing some angle in standard position. So I'm going to be starting here on the positive x-axis when I draw this angle, theta. And it says the angle drawn in standard position goes to the point negative 15, negative 8. So negative 15 on the x, negative 8 on the y. Let's say that that's this point on the circle here. So here's the point. Negative 15, comma, negative 8 it's on some circle. Right. So when I draw this angle, say this angle here, there's theta. and it ends at a point, a terminal side. This is in quadrant 3, right? If both the x-coordinate and the y-coordinate are negative, we're in quadrant 3. So here's an angle that ends at a side where the point, with a point -15, -8 on it. All right, and this angle has this reference angle. Right, here's theta prime, and I'm going to draw a right triangle with that reference angle in it. So again, from the point on the circle, I draw a segment perpendicular to the x-axis, always to the horizontal axis. And you see the right triangle I have just created. Now we're told here that the x-coordinate, right, this horizontal side, the x-coordinate is -15. The y-coordinate, right, the vertical side, is -8. So this side has a length of 8 units. This side has a length of 15 units. The only thing we're missing in this right triangle is the r, right? What's the radius of this circle? So r equals, I do not know. But I can use, right, the Pythagorean theorem. Now I can go, -15 squared, or just 15 squared, right? Because again, if you're squaring something, it's going to be positive. So, 15 squared plus -8 or 8 squared will be equal to the hypotenuse squared, right? That radius squared. This is 225 plus this is 64 equals r squared. So r squared equals, this is 289. All right, and 289, the square root of 289 is 17. So r equals plus or minus 17. But again, this is r. R is a radius, a positive quantity. All right, so on my picture then, r is 17. This is a radius of 7. So I'm on a circle now, right? Not the unit circle, obviously, because it doesn't have a radius of 1. I'm on a circle with a radius of 17. All right, then we're asked for, what's the secant of this angle? What's the secant of this angle that I just drew? Well, remember, secant is the reciprocal of cosine. Cosine was the x-coordinate of your point on the circle divided by the radius. So this is the other way around. It's the radius divided by the x-coordinate. The radius of this circle is 17. Divided by the x-coordinate is, -15. So this will be -17/15. Right, a positive divided by negative is negative. So back what I enter here, -17/15 as a fraction. Make sure it's negative, right? If it's going to be negative, don't forget your minus signs. And they do basically the same thing I did, right, without the picture, right? I always like drawing a picture, as you have seen. All right, so I'm going to do one more of these, and I've pretty much drawn the same picture every time, right? So you're going to see me do it again here. This is the same kind of problem. Again, I'll draw it again. All right, so if the terminal side of an angle theta goes through the point -7, -24. So again, we're in quadrant 3. All right, both the x-coordinate and y-coordinate are negative. Find the secant of theta. All right, so I'll draw this one more time. All right, so again, notice how repetitive I am. I do the same thing. So here's some circle centered at the origin with an unknown radius. Again, not the unit circle every single time. I'm drawing an angle that is going to end in quadrant 3. I want it to go through the point, let's say it's here, -7, -24. Let's say that point is here on this circle with the unknown radius. All right, so there's -7, -24. I'll draw this angle, standard position. So I could draw it this way if I want. Right, here's a negative angle. As long as I end here in quadrant 3, where I'm going, so here's theta, and then the reference angle, right, would be this angle here, right, between the terminal side and the horizontal axis. There's theta prime. I draw a right triangle, going from the point on my circle, draw a perpendicular segment to the x-axis, and you see this right triangle I've just created. Now I know the horizontal length, right, is -7, right? This is the x-coordinate here, x -7. So this side has a length of 7 units. The vertical length, y equals -24. The y-coordinate is -24. So this side has a length of 24 units. And again, we just don't know the radius of this circle. Right? We don't know how far this point is from the origin, or what's the hypotenuse of this right triangle. All right, so we got -7 squared plus -24 squared equals the radius squared, the hypotenuse squared. This would be 49 plus, let's see, it's 28, 56, 576 equals r squared. Adding these together gives me 625 equals r squared. And then square root of 625 is 25. So r equals plus or minus 25. But again, we're talking about r here. The radius should, the hypotenuse for all these triangles should be a positive quantity. All right, so this is 25. So I'm on a circle with a radius of 25 units, right? So definitely not the unit circle. And we're asked yet again to find the secant of this angle, which is the reciprocal of the cosine. So it's the radius of the circle divided by the x-coordinate of your point on that circle. So 25 divided by, and then the x-coordinate's -7. So this would be -25/7. And I'll just do the cheat instead of typing it in. -25/7 as stated. You see how the picture I'm drawing every single time is the same. I make my coordinate plane. I draw some unknown radius circle around the center, and then draw my picture from there. Make sure I get a right triangle with the reference angle in it, and set up the side lengths, find the missing side lengths. Alright, so I'm going to do this one more time here, and then kind of just hit the instructor cheat the rest of the way. So given that the cotangent of an angle is -8/15, and theta ends in quadrant 4, we can find the other 5, right? I'll find the other 5 as well. All right, so back to here. Fancy that. Look, I'm shocked. I'm drawing the same kind of picture, right? So again, this is some unknown radius. I just drew a circle centered at the origin with an unknown radius. Now we are told this angle theta, well, let me give you the information. We're told that the cotangent of theta is -8/15. And theta is in quadrant 4. All right. So I'm going to draw just some generic angle that ends in quadrant 4 here. All right, there we go. There's an angle that ends in quadrant 4. Now this is a negative angle I drew. All right, so the reference angle, theta prime, right, would just be the opposite of that. All right. And then I draw a little right triangle, like I like doing. Take the point on the circle that the terminal side hits, and draw a perpendicular segment to the horizontal axis. And do you see the right triangle again? And I'm going to set this triangle up so that the cotangent of my angle end up being 8/15. The cotangent of the reference angle is 8/15. So 8 will be the adjacent side, right, adjacent to the reference angle, and 15 will be the opposite side, right? Because remember, cotangent's adjacent over opposite, right? Tangent was opposite over adjacent. So in my triangle here, the adjacent side has a length of 8. The side of the horizontal, so x is 8. Right, so this point here has an x-coordinate of +8, and its y-coordinate will be negative, and that's the opposite side. Right, the opposite side is the y has a length of 15, but because you're going down here, that's negative, right? So this is negative 15. So the x-coordinate's 8, the y-coordinate's negative 15. The only thing I'm missing is r, and I'll tell you right now, r is 17. Right, because 64 plus 225 is, we've seen this, is 289, and the square root of 289 is 17. So this is another circle with a radius of 17 units that I've drawn here. All right, so I've got the x and y coordinate of the point on the circle. I've got the radius of the circle. I can find all this stuff. So remember, the cosine of this angle is the x coordinate of my point divided by the radius of the circle, would be 8/17. The cosine of this angle would be positive 8/17. And so the secant of this angle, right, would just be the reciprocal of this, positive 17/8. The sine of this angle is, again, the y coordinate divided by the radius, so negative 15/17. And if that's the sine, then the cosecant would be negative 17/15, right, just the reciprocal. And we were given the cotangent, right, so the tangent is just a reciprocal of that. Right, the tangent of theta, if the cotangent is negative 8/15, the tangent would be negative 15/8. All right, so if you're given the value of one trig function and you know where your angle ends, you should be able to figure out the other 5, right, by drawing a nice little picture of a right triangle with the reference angle in it. All right, so I'm just going to do the cheat. All right, we said the secant was 17/8 and the sine was negative 15/17. All right, you'll see that come up here. All right, 17/8 for the secant, negative 15/17 for the sine, right, using that little picture. Now, again, they're not drawing pictures, but draw a picture. Makes it way easier, in my opinion. Okay. Yeah, so this is similar to a problem earlier, but this time you're in quadrant 2, right? Negative x coordinate, positive y coordinate. And you're asked for the cosecant, right, instead of the secant. Cosecant would be the radius divided by y, right? Just the reciprocal of sine. So I'll leave that to you. And again, you're going to see different problems, and they're all done in the same fashion. You probably have noticed, right? I've been drawing the same kind of freaking picture every single problem. Right. This is basic. Now here, this one I'm in quadrant 4, positive x, negative y, and then find the secant. So that'd be radius over x. All right. And I'm just going to fly through, see if any other different kinds of problems show up. I think I've shown you enough how to do these problems. All right, yeah. So here, again, we're given the sine of an angle. You can think of this as like opposite over hypotenuse when you draw your right triangle. Theta is in quadrant 2, so you're drawing a picture again, finding the cosine. Or you could use the Pythagorean identity, right? That sine squared plus cosine squared equals 1, and solve for cosine, and just make sure it's going to be negative, because remember, if you're in quadrant 2, cosine should be a negative number. So I'll leave that kind of a I've done something similar already several times. So let's see. Again, I'm just kind of scanning through here just to see if any other kind of problem shows up. Okay, so this one, yeah, this is no different than the last one. So I'm just going to have it cheat for me. Okay, this one again, remember this is just what quadrant would angle theta end in if you know the cotangent of it is negative and the cosine is negative. All right, so I can say this one real quick. If the cosine is negative, well, first of all, if the cotangent is negative, it's in quadrant 2 or 4. And if the cosine is negative, that means x coordinates are negative, and between quadrants 2 and 4, only quadrant 2 has negative x coordinates, so this is quadrant 2. You just got to pay attention to your x coordinates and y coordinates, really. Okay, same deal. I already mentioned, where is the cotangent negative? Quadrant 2 or 4. This one's one of those where you enter multiple stuff. That's probably the easiest of the objectives. And then yeah, I did several of these. Again, you're drawing a picture and finding the value of the other 5 trig functions. Well, here, just 2 of them. But I would practice writing down all 5. What are the other 5 trig functions if you know the cosine, Draw your picture, right triangle, all that stuff, reference angle, set up the side lengths, find the x coordinate, y coordinate of some point on the circle, and then the radius of that circle, and you should be able to find all the other trig functions. So I'm just going to have it cheat for me again. I have shown you several problems like that already. And this is also no different. Right, again, just pay attention to the trig function you're given, though, right? Because remember, all the trig functions are defined in different ways in a right triangle. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then you have all the reciprocals. So just pay attention to what trig ratio they give you. I believe that'll be it. Yeah, okay. So hopefully this video here was a good way, you can use it as a decent guide for when you go through section 7.4 part 2 as assignment on your own. Right, you're going to see stuff in a different order, maybe even different problems than I do, but the way I would go about them is the same. Right? And again, you notice how almost all these problems, I have my coordinate plane, I drew a circle with an unknown radius, I figured out where my angle was going to end, and then what point on the circle would I get a point on the circle, draw a segment perpendicular to the x-axis to create a right triangle with the reference angle in it, and then set up those sides, find those missing sides, find the coordinates of the point, the radius of the circle, and then you could find all the trig functions. I mean, it sounds like a lot, but you saw, if you get good at it, you practice it enough, it doesn't take that long to make those drawings. Okay, so hopefully this is a good guide for you, and enjoy working on section 7.4 part 2 on your own, and let me know if you have any questions, of course, in Canvas. Thank you very much for watching.